Hello, this is Isidro. In this tutorial I'm going to talk about central counting, which lets you count things somewhere in the level and bring that information over to a central position and have that information transferred. This opens up some gameplay opportunities, and it allows you to count elements and store that in a central position, so when your counting element is destroyed, your information is still stored safely in a central spot. So you can use this for emitted objects that contributes to a count. For example, to do this, we'll start by adding a one-shot counter in the beginning. And those counters are set to type 1 and they reset themselves. So our button will go in there and it will simulate our input, and this will go into our temporary counter. Okay, so this, let's say the target count is 5. This is important as it stands for the capacity of our element to hold the information. Like I made it 5, like our ship can only hold 5 items, let's say. Okay, it's going to go up on to 5 and it won't go up anymore afterwards. So for this one to be transferred, I need to use signaling mechanisms. So whenever there's something to be counted, I need to have it on. For this one, I have to make this an inward output. So and I'm going to connect it with a tag. So this tag is active whenever there's something to be transferred. Okay, I'm going to label this transfer count. So I'll be signaling the center to transfer the count. Let's try. Okay, this is not working. Why? Because this is an inverted counter with a count of 5, so I need to use a direction combiner and make this a negative signal instead of a positive one. Okay, so whenever something needs to be counted, this is transferred there, and this tag is on. So when this tag is on, it needs to be sensed in the center. So we need a tag sensor here. Let's make it big. Okay, you can make it as big as you like, of course. And this will need to be given the transfer count label, and you see already it is sensing the count. Whenever this is sensing the count, it will count upwards in the central counter. Okay, let's make it bigger. And let's make the total count to 30, let's say. And I'm going to connect this over here. Okay, let's try. Okay, when this comes near enough, it's going to is still going to count 1. So you see I have much more which are not being counted, because it's our counting element that signals the center doesn't know that the count is being transferred. So we need to have another tag here in the center that tells our element that the count is received, that the request is received. So received request I gave, and this needs to be sensed here using, of course, a tag sensor. Let's make it big enough. Don't worry about making them equal size. You'll know why later. And we'll give the name. No, okay, we'll give the received request. So it's already signaling there. What it's going to do is going to remove 1. Okay, as you see, it's already removed 1. But since this is being constantly on, further items are not counted. To remedy this problem, I'll use an XOR. I'll use an XOR here. Sorry. And I'm going to connect this with an end. What I'll do is I want to break the signal for a while until the next one is counted. So I'm going to connect the end to the tag, and I'm going to connect this to the XOR, and the counter will be, when it's active, when both are active, this will be off for a while. And when these are both on, this will be disabled, and when this is disabled, it will stop giving the signal, and this circuit will break, and it will be ready to count the next one. Okay, let's see if it's working. Okay, it's doing the counting on the fly because they are so near, but it is working so far really well. Let's try. Let's take them further apart. Okay, I'm going to count them, and it's storing the information. Okay, let's try, and let's fly back to the base, and you'll see our count is transferred. Let's make them 0 to try it if it's correctly working. 1, 2, 3. Let's try with 3. Okay, we bring it over there, and what we'll see is the current count is up to 3 now. So what we've done is we've counted something elsewhere in the level, and we brought it back and have the information stored centrally. And when you can also use delay for this to have. Okay, this is basically the same chip over here, but the central part has a delay timer. Okay, let's try how this works. Let's make them further apart. Okay, I've collected some items, and I'm going to bring it over, and you'll see the count is being done slowly because you need to, for example, stay steady and unload the stuff, and it takes a while, let's say. And I've used this in an example situation that can be used in a game. Okay, let's try that out. Okay, I'm going to count. Like, okay, this is the 5th, and I can't collect anything anymore. I need to go back to the base, and I'm going to transfer those stuff over. Okay, I've collected 5 more, and something has shot at me. For example, I need to leave. I couldn't unload my stuff. That didn't sound right. Okay, so this is how it could be used. It could be used on a fly where you have a really big radius for counting, and this is a very sturdy way of counting things, as you keep the signal until you know that the central counting has been done. And this is the sensor that the received collect. So sorry, this is the one with the received request, let's say. So you know when the center has counted upwards using this one, and it is a circular signaling system, which is very sturdy. Okay, thanks for watching. I hope you like it and use it in your levels. I'm going to give this out on my Earth as a copyable and shareable level, so you can check out what I've done with these stuff over here. Okay, bye.